you really don't need to be a geography teacher to be using GIS. You can be a math teacher, you can be a history teacher, there are lots of examples of changes through time that can be demonstrated by GIS applications. You can be a science teacher. Some of the things that John is going to talk about really fit into sort of the science realm. So there's lots of different things that GIS is useful for. And so, you may have a colleague who says, oh, well, I'd never use that in the classroom. But I think that it is important to really see this as a vehicle for delivering content, just like we would think about a textbook, for example, as a way to get information to the students. And it's an interactive, hands-on kind of approach. And this doesn't say that you need to be an expert in GIS. You just need to know how to use some of the applications. And the students, in many cases, will be well ahead of you. They will know how the technology works just intuitively. Although they won't have any training in GIS, they'll be able to push forward and get stuff out of the analysis that you can get from GIS. And that's one of the big pushes that we see, because the new state standards, which Rebecca will talk about briefly at the end, at least in geography, really says that we need to have 21st century skills, those buzzwords, and this is one way of integrating those technologies into the classroom. So don't feel like you have to develop a GIS class after being in this workshop, but think about how you might be able to engage students using this kind of technology. So in light of those comments, I have a brief discussion about how this technology fits in with geography. And geography in many people's minds is just, I learned all the state capitals. I know where countries are on the Earth's surface, but the reality is that geography is a lot more than that. You really need to understand what the distribution of things are. Things are not the same everywhere, and I heard the comment coming in, is this an unusual amount of snow for around here? And the reply was, well, no, we always get this amount of snow in the winter, but it's obviously different in different places, so that we're not surprised to see variety on the Earth's surface. And what geography really should be is to think about why we have that variability and how people interact with that variability. So we have lots of different things going on the Earth's surface, and we need to think in that way about, why is something where it is. So geographers have done this for a long time. You can go back hundreds of years and find people that have done work in trying to make some kind of systematic order out of the Earth's surface. And so we have, in this case, two examples of how you might diagram out the distribution of land use in a city. So we've got different kinds of land use segregated in different neighborhoods, and there seems to be some kind of pattern. So if you think about almost any city, you can develop some kind of model that will describe what's going on. Now, I've just picked the example of a city, but of course we can always think about different kinds of distributions. And so this is really one of the main points in GIS, is that we can look at this distribution out on the Earth's surface and turn it into a map, turn it into something that we can relate to, some real organized kind of approach to figuring out what's going on out there. And the thing that's different is that today we have some sophisticated tools that folks in the past didn't have. On the left, we have a representation of what GIS looks like inside a computer. Now, we can think of a landscape, and at the bottom we have what's called the composite overlay. And that's just everything we find out there. So when we go outside, we see all these different things distributed on the Earth's surface. We can start slicing that apart and picking specific parts of the environment. And that's what all these layers are above. So we have one that's wetlands, for example. We have one that is the floodplains. We have the zoning layer. Some of these then are natural features that don't necessarily have any direct relationship to what humans have done, at least before humans showed up starting to modify the environment. We have other things that are particularly human constructs like zoning or parcels. So these are land parcels, for example. It's how we divide up the land. So we can take any place on the Earth's surface and start dividing it up. Start organizing it as to different kinds of land use or different kinds of environments. And in the GIS, that's basically what we're doing. We're separating out different layers of the environment. Now, the beauty of GIS is that if we know about what's going on in these different layers, we can put them all together and see where things correlate. So, do we find that zoning in floodplains is not appropriate? We can overlay floodplain and zoning maps and look at how those correlate. Do we put $1 million mansions on the floodplain, or do we put parks on the floodplain? Those kinds of decisions can be facilitated using GIS. So we have this kind of organization in a computer where we have these different layers representing different kinds of land use. On the right-hand side, then we have GPS. Now, we're not going to go into detail how GPS works, but we've got a bunch of satellites flying around above the Earth's surface, sending signals to our GPS units. Those satellites know exactly where they are. They're sending out signals, and the time it takes for the signal to come to the GPS unit tells the GPS unit where you are on the Earth's surface, because if if the satellite knows where it is, you can triangulate your location using the GPS. Now, you can use a GPS your entire life without knowing that. So, it gives you a relatively precise location, not only XY coordinates in terms of where you are on the surface of the Earth, but also your elevation. So giving you a Z value up and down too. So we'll use a little bit of that. Now this is a good tool for capturing data out in the field. So we can get information. We can not only locate a point, but we can also say, well, what is at that point? And so if you work for a utility company and you go out and you go to all the power poles, for example, you can record information about those power poles, and it's associated with the precise location. And then you can download that information into the GIS and develop one of these layers, the power pole layer. So you've got a pretty powerful way of collecting and analyzing data with these technologies.